A couple more, and two U-tries, which I'll provide for you later. A stone is thrown vertically at an upward rate of 160 feet per second from a height of 20 feet. That's where it's starting. Again, we're given a formula that will tell us what the height is. Basically, if I say that I threw it, I want to know how high it is after 3 seconds. What I would do, I mean, this is how these functions work. I would plug in how long it's been in the air, and this right here will tell me exactly how high it is. If you plug in a number for how long it's been in the air, whatever this works out to be, that's how high it is at that time. Now this one says, how long will it take the stone to reach its maximum height? Again, this is referring to the vertex. So I'm going to say t equals negative b over 2a. B is 160, a is negative 16, so negative 160. 2 times negative 16. This is negative 160 over negative 32, which is 5. It takes 5 seconds to reach the maximum height. And what exactly is the maximum height? Well, I'm going to plug 5 in because I said as long as I plug the time in, it'll tell me how high it is at that time. Okay, so I'm going to do h of 5. Plug it in everywhere with parentheses. And type it in exactly how I have it written. Everything. $420. Its maximum height is 420 feet. Now, those are pretty straightforward. You'll get a hang of those. Number 7, let's see. A landowner wants to fence in a rectangular area to use as a garden. He plans to use the house as one of the walls. He has 180 feet of fencing and wants to maximize the area. So let's draw a picture of this. Imagine this is his house, and he wants a fence like this. And it's going to be a rectangular thing. So I'm going to say let's say that this is x. It says use x to represent the length adjacent to the house. So this is adjacent to the house. So I'm going to say that this is that same length. Over here, I'm going to say let's call this y. And we know that that one is y also. Now this is really important. It says he has 180 feet of fencing and wants to maximize the area. When I think of area, I think of length times width. And in that case, here's the length, here's the width. So I think that the area would be x times y. But I really wish we were using all one variable instead of x and y. So what I need to do is this. I need to somehow rewrite y in terms of x. Here's how we're going to do that. This is a pretty advanced problem, so stay with it. I want to point out something. It says he has 180 feet of fencing that he wants to use to make this fence. So I want to point out that if we add all these together, these should all combine to be 180. So x plus y should all add up to be 180. Okay, all three of these pieces are gonna be made of the 180, so I'm gonna add them all up. They should equal to 180. This is x plus 2y equals 180. Let me combine those terms. What I want to do is solve for y here. I'm going to get y alone, so I'm going to move this x over. And I'm going to divide by 2. 180 over 2 is 90. What we'll do then is this. I'm going to take this and I'm going to plug it in place of y. This is like substitution. So area equals x times y, and I'm going to replace the y with this. I'm going to distribute this through here. 90x, and then minus x squared over 2. I'm actually going to write it in the other way because I like the x squared term to come first. And I'm also going to do this negative 1/2 x squared. Instead of writing x squared over 2, I'm going to do negative 1/2. It is negative, by the way. Plus 90x. It was a positive 90x, so I'll do that. This is pretty advanced. I'll just say that. It's pretty weird. Find the length x that will maximize the area. So here's the area. If I'm thinking maximum, I'm thinking vertex, and so I should just do what I know to do with a vertex. So x equals negative b over 2a. Well, b in this case is 90. And a in this case is negative 1/2. If I work this out, 2 times negative 1/2 is negative 1. This is positive 90. That's the length. This should be 90. Okay, this should be 90 in order to get the maximum area. We're trying to build the biggest thing that we can. What does that mean y is? Let's see. Well, we did, a couple ways that we could do this, but we did solve for y. We could use that. So we should plug 90 into here, or we could just plug it into here. Okay, because we know that these should all add up to be 180, or at least x plus 2y's should equal 180. Oh, well, you know what? I don't even need to do that. We don't need to do that, sorry. It says find the maximum area of the garden. All I need to do to find the area of the garden is use this area formula that I created. And I'm just going to plug in 90. And I'm definitely throwing this in the calculator. Negative 1/2, parentheses 90 squared, plus 90 times 90. 4,050. The maximum area is 4,050 square feet. This is a tough one. It's a seriously tough one. So I suppose there is a U-try based on it, and we'll definitely have to work through that together on Wednesday. Otherwise, I hope you like this new video. Let me know how the audio is. I'm not sure where the microphone is. Yeah, cool.